Today we're going to talk about control. You know, in our digital world, pretty much everything is locked behind some kind of door, and every single door needs a key. So we're going to break down how you manage who gets which keys, especially when your world just keeps getting bigger and bigger.
Okay, let's just dive right in. Picture this. Your company is taking off. You're hiring new people for all kinds of different jobs. Now, you have to give them access to do their work, right? But you can't just hand everyone a master key that opens every door. I mean, that's a total security nightmare. And that is the central challenge for any modern business running things in the cloud.
And here is the solution, at least if you're in the world of Amazon Web Services. It's called IAM, which stands for Identity and Access Management. The best way to think of it is like your digital locksmith. It's this one central place where you create your users, you manage their keys, and you decide exactly what they can and can't do.
To really get a handle on IAM, you only need to know about three basic, let's call them building blocks. First, you've got your users. Those are the actual people or even applications that need the keys. Second, you have groups, and trust me, it's way easier to manage a support staff group than 50 individual people. And third, and this is the most important piece of the puzzle, policies. These are the rules that define what the keys can actually open.
Now, I know the word policy can sound a little, corporate and intimidating, but it's really not. A policy is just a simple document that says, hey, you are allowed to do this one thing, or nope, you are denied from doing that. It's basically the instruction manual for the lock.
And check this out. This slide really breaks down how simple these rules are. Every rule has just three parts. You've got the effect, which is either allow or deny. Simple enough. Then the action, which is what someone can do. And finally, the resource, what they can do it to. That could be one specific file, or as you can see with that little star, it could mean literally everything. Really, it's that simple. Okay, so theory is one thing, but let's see how this stuff actually plays out in the real world, right? We're going to walk through a scenario based on our source material, where a company is bringing on some new people with totally different jobs.
So, meet our new team. We've got user 1, who just needs to look at data storage. Then there's user 2, whose job is to monitor the company's servers, but definitely not change them. And then you have user 3, an administrator who needs the power to actually turn those servers on and off. 3 different people, 3 very different sets of keys required.
So how do we handle this? Well, you're not going to create custom keys for each person. That would be a mess. Instead, we just drop them into the right group. User 1 goes into S3 support. User 2, EC2 support. User 3, EC2 admin. Each of those groups already has a policy attached, so the permissions get applied automatically. It's super efficient and it scales perfectly as you hire more people.
All right, the setup is done. But here's the million-dollar question. Did it actually work? Does everyone have exactly the access they need and absolutely nothing more? Well, let's sign in as each user and find out.
Okay, first up, let's log in as user 1. Remember, their job is all about supporting the company's data storage. They just need to be able to see the storage buckets and what's in them. Let's see what happens. And it works perfectly, just like it's supposed to. User 1 can log in, head over to the S3 service, and see all the data they need. But the second they get a little curious and try to peek at the company's servers, bam, completely blocked. The system denies them access flat out.
And this right here is what I love about IAM. It's not a suggestion. It's a hard wall. The system gives back this crystal clear, unambiguous error. You are not authorized. The policy is doing its job, keeping user 1 in their lane.
All right, on to our next test subject, user 2. This is our EC2 support specialist. Their policy is supposed to give them read-only access to the servers. They have to see them to do their job, but that's it.
So they log in, and yup, they can see the lab host server instance. So far, so good. But here's the real test. Read only is the key phrase here. What do you think happens if they try to actually do something, like try to stop that server?
Denied. Again. And this is so important. User 2 gets an instant failure message. They can look, but they can't touch. This shows you just how granular, how specific you can get with these policies. It's not just about can you see this service, it's about what tiny specific actions you can take inside it.
Okay, time for the grand finale. Let's log in as user 3, the EC2 administrator. Their policy should give them the power to not only view the servers, but also to start and stop them. This is the person with the really powerful keys.
So user 3 logs in, they cruise over to the EC2 console, select that same lab host instance, and click Stop. And this time, what happens? Success. The instant state immediately changes to stopping. User 3 had the exact permissions needed, permissions that the other two were correctly denied.
So we've seen 3 users, 3 jobs, and 3 totally different outcomes, all perfectly controlled. So what's the big takeaway here? Why does this simple little story matter so much for how modern companies work?
It's because this whole thing perfectly illustrates a core idea in all of cybersecurity. It's called the principle of least privilege. And the idea is actually incredibly simple, but it's profound. You give every single user the absolute minimum level of access they need to do their job, and not one single permission more. User 1 didn't need server access, so they didn't get it. User 2 didn't need to stop servers, so they couldn't.
And why is this so crucial? Well, for one, it massively cuts down on the risk of accidents. No one can accidentally delete something they don't even have permission to touch. It also limits the blast radius if an account ever gets compromised. An attacker who steals user 1's password can't shut down your company. It protects your data, and it makes security audits way, way simpler. So, at the end of the day, controlling the cloud is all about being a smart locksmith. By giving each person only the keys they truly need, you build a system that's more secure, easier to manage, and way more resilient. It turns a huge, complex security problem into a series of simple, logical rules. Which leaves us with one final thought for you. Who holds the keys in your organization?